Ever heard of a floating signal in electronics? You might think it's just a neutral, in-between state. But in the world of digital circuits, a floating signal isn't neutral at all. It's actually quite dangerous. It's an open door for chaos, a state of pure unpredictability that can wreck your entire project. So, what exactly is happening here? In digital electronics, everything is about ones and zeros, high and low, true and false. An input pin on a microcontroller, for example, is designed to read either a high voltage, let's say 5 volts, or a low voltage, like 0 volts. There's no middle ground. But what happens if that input pin isn't connected to anything? It's not high and it's not low. It's just floating. When a pin is floating, it's like a tiny antenna. It can pick up all sorts of electrical noise from the environment. Static from your clothes, radio waves from your Wi-Fi router, electromagnetic interference from nearby power lines. All of this can randomly make the pin's voltage bounce up and down. To the microcontroller, it looks like a frantic, non-stop switching between high and low. This can cause your code to behave erratically, triggering functions when it shouldn't, or getting stuck in loops. It's a recipe for disaster. This is where the humble pull-up resistor comes to the rescue. Imagine you have a switch connected to a microcontroller input. When the switch is closed, it connects the input pin to ground, giving you a solid low signal. But when the switch is open, what then? The pin is left floating. A pull-up resistor solves this elegantly. It's a resistor connected between the input pin and the high voltage source. Now, when the switch is open, the pull-up resistor gently pulls the voltage on the input pin up to the high level. It's not an aggressive, forceful connection. The resistor's high value means only a tiny amount of current flows, just enough to establish a default high state. Then, when you close the switch to ground, the path to ground has much lower resistance. So the voltage on the pin drops to a solid low. The pull-up resistor ensures the pin is always either high or low, never left to float in uncertainty. You'll also see pulled down resistors, which work the same way, but connect the pin to ground, establishing a default low state. The choice between them depends on whether you want your default state to be high or low. The key takeaway is this: pull-up resistors don't add new logic to your circuit. Their job is much more fundamental. They remove uncertainty. They provide a default state, ensuring your digital inputs are always defined and your system behaves predictably. It's a simple component that brings order to the potential chaos of a floating pin.